अच्छा, वन मोर थिंग, देयर वाज अ असेसमेंट आफ्टर द क्लास ना, उसमें से कोई सवाल है जो मतलब आप लोगों को नहीं आया हो तो बताइए। आई थिंक इरम एंड फायजा वर द ओनली वन हु गेव द टेस्ट, बाकी लोगों ने नहीं दिया था। फहद, तारीफ एंड एवरीवन डिड नॉट गिव। राबिया ने दिया था, राबिया इज नॉट प्रेजेंट टुडे।
So I had in fourth one.
फोर्थ वन, जस्ट अ सेकंड।
Sir, that test can explain the third question.
थर्ड क्वेश्चन, थर्ड क्वेश्चन
Yes,
तो
sir.
आसान था। थर्ड क्वेश्चन में क्या दिक्कत हो गई आपको?
Sir, I tried. I'm not getting the top questions.
ऑप्शंस नहीं आ रहा है आपको? दिस इज द थर्ड वन ना।
Yeah, sir.
1 mole of heptane, कितना मोल? 1 mole of heptane was mixed with 4 mole of octane. 1 mole of heptane has a vapor pressure 92 mm of Hg. Octane has a vapor pressure of 31 mm of Hg. What the vapor pressure of resulting ideal solution is? First of all, calculate the mole fraction. Mole fraction of heptane will be equal to what? 1 upon 1 plus 4, that is 5. Mole fraction of octane will be equal to how much? 4 upon 5. Okay? Now what you need to do, you need to have P total is equal to P naught of heptane into mole fraction of heptane plus P naught of octane plus mole fraction of octane. P naught H is equal to 92 into 1 upon 5 plus octane का 31 into 4 upon 5. कैलकुलेट कर लीजिए, आंसर आ जाएगा। नहीं आ रहा आंसर? What is 92 upon 5? 18.4 plus 31 into 4 will be equal to how much? 120 और 4 124, 124. Now 124 divided by 5, 5 2s are 24 and then 5 8s are 48, है ना? So this will be 18.4 plus 24.8. 43.2. C is the correct answer. Okay, and fourth one बोल रहे थे ना? The vapor pressure of pure liquids A and B are 400 and 600 mm of Hg respectively at this much temperature. A or B option हमने लिया है, C or D option. Wait a second, guys. Okay. The vapor pressure of the final solution and the mole fraction of components A and B in the vapor phase are respectively how much? तो सी वन ऑफ, देखिए एमसीक्यूज में तो आपके लिए आसान है ना, यू कैन जस्ट प्लग इन द वैल्यूज एंड गेट द आंसर्स, है ना? पीटी इज इक्वल टू पी नॉट ए का ये प्लस पी नॉट बी का बी. Plug in these values 400 600 0.5 0.5 और 500 and then see कौन सा ऑप्शन होगा नहीं होगा. ठीक है? Okay, wait a second. This question is not complete. यहाँ पे वेपर फेज में पूछ रहे हैं ना. The vapor pressure of pure liquids A and B are 400 and 600 mm of Hg respectively. ठीक है, this is incomplete. क्वेश्चन सही नहीं है ये वाला. Just a second, let me report this. The actual question was vapor pressure of A, it is equal to 400 mm of Hg and B का है 600 mm of Hg. ठीक है, 400 mm of Hg and 600 mm of Hg. This is for the pure vapor pressure of liquid A and B. And then they are saying that on mixing two liquids, the sum of their initial volume is equal to the volume of their final mixture. That means these are ideal solution. Okay? It is going to follow the Raoult's law. Then they said that mole fraction of liquid B is 0.5 in the mixture. Chi B mixture में कितना है? Solution में it is 0.5. तो chi A कितना हो जाएगा? This will also be equal to 0.5. सही है? Yes or no? Please tell me. This much is given.
Yes, sir.
Okay. And then they're asking about what is the YA, what is YB? That means the mole fraction of A in vapor phase, mole fraction of B in vapor phase, and also the P total. Okay. P total calculate करना तो बहुत ही आसान हो जाएगा. P total will be equal to how much? P naught A chi A plus P naught B chi B. तो P naught A है आपके पास 400 into 0.5 plus 600 into 0.5. कितना हो जाएगा ये? 400 का आधा 200, 600 का आधा 300, 500. Okay. Now we have also seen what chi A into P naught A. P naught A नहीं, chi A into chi A into P naught A will be equal to YA into P total. This we have also seen. वेपर फेज वाले सवाल में देखिए, है ना, you see here PA partial pressure of A is equal to YA plus PT. What is PA equal to from Raoult's law? PA it is equal to P naught A chi A. ठीक है, PB is equal to P naught B chi B. ठीक है, that's the equation I am using here. Now chi A is equal to 0.5. YA आपका कितना हो जाएगा? YA will be equal to 0.5 into 400 divided by 500. So this will be equal to 200 divided by 500. 2 by 5 हो जाएगा ये. 2 by 5 यानी कि 0.4. YA 0.4 है, YB कितना हो जाएगा? 0.6. C option will be correct here. Sorry, C, B option. 500 is the total. 0.4 is the mole fraction of A. 0.6 is the mole fraction of B. ये सवाल पढ़ा दीजिए, ठीक है? ये सवाल is not right. This is the given information. A is equal to 400 mm, B is equal to 600 mm, chi B is equal to 0.5. They're asking YA, YB and P total. इरम समझ में आया आपको?
Yeah.
Done everyone? Yes or no? Please tell me. Yes, Iram, Fahad, Faiza, Tarif, done.
Yes, sir.
Faiza, also just retry logging in after the class, okay?
Yes, sir.
Moving on towards ideal solution and non-ideal solution, okay? Ideal solution and non-ideal solution at the topic. First of all, what is ideal solution? Please write. Anything that follows the Rawls law over an entire range of concentration, that is known as ideal solution. Please write. This would follows Rawls law over entire range of concentration. क्या मतलब है इसका? What is the meaning of this statement? Please. According to Rawls law, the total pressure of the solution should be equal to P naught A chi A plus P naught B chi B. Now, before making any solution, before we start to make any solution, what we can do? We can look up the vapor pressure of the pure solvent and a vapor pressure of pure A. Now, I'm still not making the solution. हम एक considerable mole fraction ले सकते हैं 0.3, 0.2, 0.1, anything. So chi A also can be written as it is without doing any experiment. Similarly, P naught B can be taken from the literature. What is the vapor pressure of pure liquid B? And chi B can also be taken theoretically. I can write all the values of P naught A chi A plus P naught B chi B without doing any experiment. And उसके बाद इन सब को कैलकुलेट करने पे जो प्रेशर आएगा, this will be the theoretical pressure, or we can say the calculated pressure. ध्यान से समझिएगा इसको. I have not done any experiment till now. I have said that let us suppose I will take benzene, I will take toluene. Benzene का हम लेंगे 0.6 moles. The mole fraction of benzene I will take is 0.6. The mole fraction of toluene I will take, that will be 0.4. And then I will mix them. And then I calculated the total pressure. So this is the theoretical pressure. I have not done any experiment. After that, what I did, I took benzene, I took toluene, I mixed them, and then I put a manometer here, which is going to read the pressure. So I will do the experiment and I will get the experimental pressure or the observed pressure. Okay? I will get the observed pressure. Now, if the calculated and the observed pressure are same, we will say that it follows Rawls law. है ना? तभी तो ये solution का observed जो है, that is equal to calculated. That means it is going to follow the Rawls law. Is this understood? Yes or no? Please tell me. What is the meaning of this statement? All of you, Iram, Fahad, Tarif, understood? Yes, guys. Iram, Tarif, Fahad, understood? Yes or no? Please tell me.
Yes.
Yes, sir.
Yes. Okay. Now, this ideal solution, what it does, it follows the Rawls law. Now, क्या मतलब है follow करने का Rawls law? What is the meaning to follow the Rawls law? We have also seen that. Experimental. I will write the first statement. Delta P. Difference in the pressure, that is equal to pressure that is observed minus pressure that is calculated. Okay? Observed pressure is the experimental one. Calculated pressure is the theoretical one. This should be equal to 0. दोनों के दोनों same होंगे, then only it will be equal to 0. Then only it is going to be equal to 0. Now, where does it arise from? Why do we have the same vapor pressure? It is because, let us suppose when we have the liquid A, the A molecules will be interacting with each other, right? There will be some force of attraction between these A molecules. Similarly, liquid B will also be having some molecules, and there will be some force of attraction between these B molecules. All of these B molecules are interacting with each other. Now, when I am going to mix in the solution of A and B, we will have A, B, B, A. And these molecules will be having some intermolecular forces of attraction. The vapor pressures will only be same if the molecular interaction between in the pure component is equal to is same as the intermolecular forces of attraction in the solution. Why? Because if it is same, then the same amount of vapors will be formed. And if we have the same molecular interaction before dissolving, before mixing and after mixing. Before mixing, we are having some intermolecular forces of attraction. After mixing, we are having some intermolecular forces of attraction. If both the intermolecular forces of attraction are same, then only we can say that same amount of vapors will be escaping out. Now, दोनों की escaping tendency before mixing and after mixing same है. That is why same number of vapors are formed. That is why the vapor pressure is same. So what is the basic criteria? Underlying criteria क्या है? Intermolecular forces of attraction. Now that means in order to make an ideal solution, एक ideal solution बनाने के लिए क्या रहना चाहिए? The intermolecular forces of attraction of A and B should be same, should be similar. ठीक है? So what type of liquids are going to form ideal solution? Please write. Note. Ideal solution, or rather write like this: liquids with similar intermolecular force of attraction forms, or rather form होगा ना, liquids है तो form ideal solution. For example, these examples are very important. ठीक है, examples याद भी करना है आप लोगों को. Benzene and toluene, hexane, other N-hexane, normal hexane, and normal heptane, chloroethane and bromoethane. Done everyone? Yes or no? Please tell me.
Yes, sir.
Next देखते हैं. What are the characteristics of ideal solution? बहुत ही आसान है. Logically सोचेंगे सब कोई. Characteristics of ideal solution. Tell me. if the intermolecular forces of attraction are same before mixing and after mixing, that means in terms of forces of attraction, there is no change happening. Yes or no, please tell me. In terms of forces of attraction, there is no change happening before mixing and after mixing. Is that true? Yes or no, please tell me.
Yes.
Right? That means neither new types of attraction is being formed, nor we are destroying any type of attraction. है ना? ना ही नया कोई attraction बन रहा है और ना ही क्या हो रहा है, ना ही आपके पास कोई attraction क्या हो रहा है, destroy हो रहा है. That means the enthalpy of mixing will be equal to 0. Enthalpy of mixing क्या हो जाएगा? There is no change in the enthalpy. Neither heat is released. Heat release कब होता? If new bonds were formed, if new attractions were formed. And when is the heat required? Heat is required when the attractions are destroyed. जब attraction को destroy कीजिएगा तब heat required होगी. So delta H mix is equal to what? It is equal to 0. Second, if the forces of attraction are same, the molecules will be occupying the same space. And molecules will neither be far apart from each other, neither they will be very attracted towards each other. That is why change in volume will also be equal to what? 0. The change in volume will also be equal to 0. These are the two main things. Now, moving on. Third, delta G of mixing. When delta H, it is what? It is equal to 0. In that case, delta G will be completely dependent on the entropy. So what will be the entropy? As you know, we have V1 and then you will add another liquid V2. Basically क्या हो रहा? Volume is increasing, है ना? Total volume क्या हो जा रहा है? Increase कर जा रहा है. पहले liquid A के पास, for example, 500 ml था, A का, and 500 ml B का. So A has only how much volume to roam around? 500 ml. B had only 500 ml to roam around. When you added both of them, तब A के पास भी कितना है? 1 लीटर है घूमने फिरने के लिए. Okay, so it can revolve around 1 liter. So if the volume is increased, what happens? Entropy also increases. So delta S will be what? Delta S for ideal solution is positive. And that is why delta G will be what? It will be negative. To write these things.
So,
Tell me.
so can you please explain again how is delta G negative?
Delta G is equal to बताइए, what is the formula? Thermodynamics. Delta H minus
T
T
delta.
delta S. Delta S क्या है? Positive. Delta H क्या है? 0. तो delta G क्या हो जाएगा? Positive into negative, negative. Temperature तो क्या हो सकता है? Temperature is always positive ना? Temperature कभी negative होता है यार?
नहीं.
और -5 होता है जो डिग्री सेल्सियस, वो किस लिए होता है? क्या बोलिएगा? What will you say? कोई बोलेगा अगर तो -5 तो होता है. आप बोलिएगा साइंस में केल्विन लेते हैं. साइंस में क्या लेते हैं?
Kelvin.
केल्विन लेते हैं, है ना? तो केल्विन में सब चीज पॉजिटिव ही होगा. ऑल द टेम्परेचर्स आर पॉजिटिव. ठीक है. कोई भी एक तो लाइक दिस इज वेरी इलॉजिकल इफ यू थिंक अबाउट इट. You are measuring from something and it is negative. अरे आप किसी चीज को अगर मेजर कर पा रहे हैं, फॉर एग्जाम्पल डिस्टेंस, है ना, डिस्टेंस को अगर कोई मेजर कर पा रहा है यानी कि डिस्टेंस पॉजिटिव नहीं है ना. ओके, सो दिस डिग्री सेल्सियस, दैट इज व्हाई डज नॉट मेक सेंस एंड दैट इज व्हाई वी यूज केल्विन स्केल. ठीक है, तो टेम्परेचर विल ऑलवेज बी पॉजिटिव, डेल्टा एस भी पॉजिटिव है, तो नेगेटिव इनटू पॉजिटिव विल बी इक्वल टू व्हाट, नेगेटिव. समझ में आया, यस और नो? इरम,
Okay. Yeah.
चलिए, डन एवरीवन, यस और नो, प्लीज टेल मी.
Yes, sir.
नेक्स्ट वी हैव नॉन आइडियल सॉल्यूशन. आइडियल को कैसे लिखा था हमने? ब्लू से लिखा था. What are non-ideal solution? They do not follow Rawls law over entire range of concentration. क्या मतलब? मतलब ये हुआ, pressure that is observed will not be equal to pressure that is calculated, है ना, ये तो मतलब हुआ. ठीक है, that means delta P, which is equal to pressure that is observed minus pressure that is calculated, this will also not be equal to 0. चलिए, अब देखते हैं types of non-ideal solution. Now, please see, write the topic. Types of non-ideal solution. पहले केस क्या हो सकता है? पहला केस ये हो सकता है, the pressure that is observed that is greater than pressure that is calculated. Second type will be pressure which is observed is less than pressure that is calculated. इस केस में डेल्टा P क्या होगा? पॉजिटिव हो जाएगा. एंड इस केस में डेल्टा P क्या हो जाएगा? डेल्टा P विल बी इक्वल टू नेगेटिव, है ना. ऑब्जर्व्ड अगर ज्यादा है, ऑब्जर्व्ड इज ग्रेटर देन कैलकुलेटेड तो पॉजिटिव, ऑब्जर्व्ड इज लेस देन कैलकुलेटेड तो नेगेटिव. तो इसी पे हम लोग क्या बोलते हैं? वी कॉल दिस डेविएशन एज पॉजिटिव डेविएशन फ्रॉम रॉल्स लॉ. And this is known as negative deviation from Rawls law. सिंपल सा नाम है, पॉजिटिव डेविएशन और नेगेटिव डेविएशन. क्लियर है? यस और नो प्लीज टेल मी.
Yes, sir.
ठीक है, नेक्स्ट देखते हैं अब पॉजिटिव डेविएशन होगा क्यों और उसके क्या क्या कॉन्सिक्वेंसेस हो जाएंगे. तो फर्स्ट ऑफ ऑल, व्हाट इज द कॉज ऑफ पॉजिटिव डेविएशन? सी हियर. Now the pressure is more than the calculated one. Pressure is more than the calculated one. That means vapor pressure. Vapor pressure क्या है आपके पास? Pressure is more. ठीक है, प्रेशर क्या है? ज्यादा है. क्या मतलब हुआ? नंबर ऑफ वेपर्स, number of vapors will be more or less. Tell me guys. प्रेशर अगर ज्यादा है तो वेपर ज्यादा है या कम है? जी, नंबर ऑफ वेपर्स विल बी मोर और लेस. जोर से बोलिएगा प्लीज.
More.
more. Very good. Number of vapors will be more. तभी तो ज्यादा pressure हो रहा है. If number of vapors are more, that means escaping tendency क्या है? High है या low है?
High.
Escaping tendency high. Escaping tendency high कब होगी? जब अंदर attraction ज्यादा होगा या attraction कम होगा? Attraction inside the solution. Attraction will be
less.
less. है ना? That means positive deviation का cause क्या है? There is worse interaction, bad interaction between A and B. A and B के बीच में क्या है? There is bad interaction. ठीक है? Now bad interaction का नतीजा क्या होगा? Bad interaction का मतलब there were some forces of attraction which are being destroyed. There were some forces of attraction जो पहले था, अब क्या हो गया? बुरा हो गया. That means there were some forces of attraction which has been destroyed, and that is why the delta H of mixing will be. Now if you have to destroy some attraction, किसी दो चीज को दूर ले जाना है, that means you have to apply some kind of energy. So delta H will be what? Positive. Similarly, if I talk about delta V of mixing, ये क्या हो जाएगा? Now, if the molecules, if the components of the solution are not interacting in a good way, if they are having bad interaction, they will be far apart. Yes or no? Attraction नहीं हो तो they will be far apart.
Yes, sir.
Correct? And if they are far apart, तो volume क्या होगा? कम होगा, ज्यादा होगा?
ज़्यादा.
Delta V mixing will be positive. ठीक है? अब उसी के opposite में in negative deviation, that means we have less number of vapors, escaping tendency is less, that means attraction has increased. Attraction has increased, that means good interaction. Between A and B, delta H. Now, if there is force of attraction कुछ आया है, so it will be exothermic, it will be negative, and the delta V of mixing. This will be also equal to what? Negative. ना इसके बारे में एक और चीज आप बताइए. इन पॉजिटिव डेविएशन, what will be the boiling point? Boiling point देखिए, when you have positive deviation, we already have higher vapor pressure, so it will be easier to reach what? It will be easier to reach the 1 atm, है ना? Boiling point क्या होता है? The temperature at which the vapor pressure of the mixture of the solution or the liquid becomes equal to 1 atm. When we have already higher vapor pressure, जब vapor pressure already क्या है हमारे पास ज्यादा है, then in that case it will be easier to reach what? It will be easier to reach the boiling point. So that is why boiling point will be lowered. आसानी से मिल जाएगा. And in this case, boiling point will be higher or increased. Done everyone? Yes or no? Please tell me.
Yes, sir.
नेक्स्ट देखते हैं इन दोनों का ग्राफ. ठीक है, वी हैव सीन ग्राफ ऑफ रॉल्स लॉ ना. ग्राफ पहले रॉल्स लॉ के ग्राफ को लेते हैं, उसके हिसाब से हम लोग देखेंगे इसको. Give me a second. Let us remove these things first of all. ठीक है ना, इनको हटा देते हैं. No. What is the vapor pressure when we are adding this? When we are adding the two liquids, what is happening to the vapor pressure? Vapor pressure is increasing. ठीक है, vapor pressure क्या हो जा रहा है? Increase हो जा रहा है positive deviation में. So for this graph it will be like this. थोड़ा ज्यादा रहेगा ना, जब जीरो है तब तो जीरो रहेगा, but in the mixture time it will be a bit high. Similar type का ग्राफ बनेगा आपका between here also, और रेड में भी आपके पास, सॉरी मिक्सचर में भी आपके पास it will be having higher vapor pressure. ठीक है, so all of these white lines, what are they showing? They are showing the positive behavior, they are showing the ideal behavior, and the red lines are showing the positive behavior. Okay, similarly अगर हम नेगेटिव के लिए बनाएं, in the negative deviation what is going to happen? In the negative deviation, less vapor pressure will be there than the ideal case. So the graph will be somewhere like this. Done everyone? Is on? Please tell me.
Yes, sir.
Let us write some examples for positive deviation. Okay, all of these are examples for positive deviation. Let me tell you what is happening, है ना. देखिए, you have ethanol. Ethanol में होता है hydrogen bond. ठीक है. So when you have hydrogen bond and you are adding cyclohexane, which is non-polar. ठीक है, cyclohexane क्या होता है? Cyclohexane is non-polar. So cyclohexane will be coming in between ethanol and it will be breaking the hydrogen bond. तो क्या हो रहा है? Attraction break हो रहा है. Similarly, water में आपके पास क्या होता है? There are 2 OH, 2 हाइड्रोजन बॉन्ड होता है पर मॉलिक्यूल. ethanol में क्या होता है, 1 hydrogen bond per molecule. So when ethanol will come in between water, it will be breaking the hydrogen bonds. Similarly, यहाँ पे hydrogen bond है, acetone में hydrogen bond नहीं है. In H2 you have 2 hydrogen bond, methanol के केस में 1 hydrogen bond. ठीक है. Now okay, so these are important. ये सारे जितने हैं ना, these are important for you. अगर इन सबको आपको नहीं भी लिखना है, तो at least write all of these 4. And these are the examples for negative deviation. इसमें let me explain this one. ये explain आपके next textbook में भी किया हुआ है. For chloroform and acetone. Structure of chloroform पहले देख लीजिए. You have carbon that is bonded with hydrogen. Carbon bonded with hydrogen, and this carbon is further bonded with chlorine, and chlorine. Then you have acetone. Acetone has oxygen with a double bond, carbon with CH3 here and CH3 here. Oxygen has lone pair electrons. Now, this carbon atom, it is connected with electronegative atom. And how many electronegative atoms? There are 3 electronegative atoms. So it becomes, this carbon becomes very highly delta positive, and it pulls the electron from hydrogen. And this hydrogen becomes very highly delta positive. And when this hydrogen becomes very highly delta positive, this oxygen can form some bond with hydrogen, and it forms hydrogen bond. This hydrogen gets so much positive charge that it forms a hydrogen bond with oxygen. And that is why in this case we have, this is non-polar. This is also non-polar. But when you are going to mix them, they will form hydrogen bond, which is what? Which is better interaction than the non-polar one. Dipole interaction से अच्छा क्या होता है? Hydrogen bond होता है. So what is the hydrogen bond? Intermolecular forces of attraction में, it is the best type of bonding that you can have. After that you will have non-polar, and then you, sorry, non-polar लिख दिया हमने. This is polar and this is also polar. My bad. ठीक है. सबसे ज्यादा अच्छा कौन सा होता है? Hydrogen bond. Strongest. After that you have polar, and then you have non-polar. Okay. So we had polar and usse acha hydrogen bond mil gaya. That is why it is showing what? Negative deviation. The interactions are better in the solution. Done everyone? Yes or no? Please tell me. Write this down and please let me know once you're done.
Done, sir.
Done? Let us move on and write the next topic, azeotropes. Please write azeotropes or solution. Which boil at कांस्टेंट टेम्परेचर। क्या मतलब है कांस्टेंट टेम्परेचर पे बॉईल करता है? प्लीज। Let us suppose you have taken a solution of liquid A and B. ठीक है, आपके पास है लिक्विड A और आपके पास है लिक्विड B। ठीक है, आपने सोल्यूशन ले लिया इसका। नाउ लिक्विड A का बॉइलिंग पॉइंट है लेट अस सपोज 100 डिग्री सेल्सियस एंड लिक्विड B का है 60 डिग्री सेल्सियस। नाउ व्हेन यू आर गोइंग टू स्टार्ट हीटिंग, जब आप हीट करना स्टार्ट कीजिएगा, सो विच इज गोइंग टू बॉईल ऑफ फर्स्ट, A और B? कौन पहले बॉईल करेगा?
B.
B will boil first, है ना? And this is the basis of what? Difference in boiling point is the basis of distillation. अगर आपको याद हो, what is distillation? Distillation में क्या करते थे? एक मिक्सचर है, उसको आपने बॉईल किया, है ना? उससे जो कुछ भी आ रहा है उसको आपने स्टॉप किया इस तरह से, एंड देन यू पास थ्रू अ कोल्ड एरिया। यहाँ से वेपर्स मिले थे पहले। तो फर्स्ट ऑफ ऑल व्हाट यू आर गोइंग टू गेट, 60 डिग्री सेल्सियस पे क्या होगा? एट 60 डिग्री सेल्सियस लिक्विड बी विल स्टार्ट टू बॉईल and the temperature 60 degree Celsius will not change until and unless all the B has been boiled. Latent heat of fusion, अगर आपको याद हो कि आप टेम्परेचर ज्यादा दिए जा रहे हैं, अब you are giving on heat, but because B is boiling right now, the temperature of solution does not change. सारा का सारा एनर्जी किसमें कन्वर्ट हो जा रहा है? To change the liquid B to vapor B. And once all the liquid B is vaporized, what is going to happen? Then the temperature of the solution will start to increase, 60 से 65 70 ऐसे होता जाएगा। But until and unless we have B present, क्या होगा? All the B will be first of all converted to vapor in boiling process, and then आपको यहाँ पे क्या मिल जाएगा? You will get pure B। ठीक है, you will get here pure B. So this is the fundamental of distillation. Now what happens with azeotrope? आपने liquid A और B को mix किया, ठीक है, liquid A और B को mix किया और liquid A और B दोनों एक दूसरे के साथ interact करने लगे। They are interacting with each other and they interacted so much so that liquid A और B अब दोनों साथ हो गए। And when they are together, they have a boiling point of, let us suppose, 80 degrees Celsius. Now, individually कितना था liquid A का? 100 degree Celsius. Liquid B का कितना था? 60 degree Celsius. ठीक है? I'm just taking some numbers. Okay, these are not exact value. नहीं इस तरह से calculate होता है. So now the solution का कितना आ गया हमारे पास? 80 degree Celsius. Okay. Now these are known as azeotrope. अब क्या होगा? This solution is going to boil at a constant temperature 80 degree Celsius. Initially when it was not an azeotrope, जब अगर azeotrope नहीं होता तो एक बार 60 degree में boil होता, and then it would have boiled at 100 degree Celsius, two different temperature. But now for an azeotrope, when we have a mixture that is azeotrope, it will boil at a constant temperature, that is only one temperature, दो अलग temperature पे boil नहीं करेगा. Okay, so this is azeotropes. Okay, all of you understood? Yes or no? Please tell me what are azeotropes and what are different other solutions. Difference between normal solution and azeotropes, all of you understood this? Yes or no? बात समझ में आई कि नहीं आई? अरे हाँ ना कुछ बोलेंगे आप लोग? इरम, फहद, फायजा, yes or no? Please tell me. No, नहीं समझ में आया। इरम, इरम समझ में आया नहीं समझ में आया?
या समझ
आया समझ में? तो हाँ ना कुछ बोलते ही नहीं आप लोग। ठीक है, now moving on. One thing that is important for azeotrope is azeotropes have same composition in liquid phase as well as vapor phase. ठीक है, liquid phase as well as vapor phase. And azeotropes are of two types. एक को बोलते हैं क्या? मैक्सिमम बॉइलिंग एजियोट्रोप, the other is known as minimum boiling azeotropes. हाँ, मैक्सिमम बॉइलिंग एजियोट्रोप कब आएगा? मैक्सिमम बॉइलिंग एजियोट्रोप्स आर azeotrophs which are formed when maximum boiling, यानी कि boiling point will be greater than both the components. Please write boiling point and maximum boiling point is what? Boiling point of solution is greater than boiling point of both components. ठीक है, boiling point of solution is greater than boiling point of both components कब हुआ था? Negative deviation में हुआ था, right? So azeotrophs, maximum boiling azeotroph कौन दिखाता है, कौन शो करता है? Is shown by solutions with negative deviation from Raoult's law. ठीक है, minimum boiling azeotrope, that means boiling point of the solution is less than boiling point of both components. Boiling point of solution is less than and this is shown by solutions with positive deviation from Raoult's law. ठीक है, समझ में आ गया सबको? yes or no, please tell me.
Yes, sir.
Let us do some questions now. Wait a second. और ऑप्शन आ रहे हैं ना, और ऑप्शंस आ रहे हैं. Just give me some more space here. If two liquids A and B form minimal boiling azeotrope at some specific composition, then क्या होगा? A and B का interaction stronger होगा A और B से. Please choose the correct option यहाँ पे. Yes, Faiza correct, Aram correct, very good. नहीं, तारीफ नो, फिर से देखिए. बात करेक्ट. तारीफ, can you please turn your mic on?
Yes, sir.
मिनिमम बॉइलिंग एजियोट्रॉप का क्या मतलब हुआ? पॉजिटिव डेविएशन और नेगेटिव डेविएशन?
Negative.
देख के बोलिए ना, ऐसे अंदाजी बोलने से क्या फायदा तारीफा। अभी लिखा है यहाँ पे हमने कि व्हेन यू आर हैविंग मिनिमम बॉइलिंग एजियोट्रॉप तब क्या होगा, पॉजिटिव डेविएशन होगा ना। if you are not writing then I cannot help you, okay? जो चीज लिखी हुई कम से कम उसको तो सही से पढ़ लीजिए। सो मिनिमम बॉइलिंग एजियोट्रॉप का मतलब हुआ नेगेटिव डेविएशन। इफ देयर इज नेगेटिव डेविएशन देन बैड इंटरेक्शन और गुड इंटरेक्शन? सॉरी, मिनिमम बॉइलिंग का मतलब हुआ पॉजिटिव डेविएशन, पॉजिटिव डेविएशन का मतलब बैड इंटरेक्शन और गुड इंटरेक्शन?
Good interact. No. Bad interaction.
ऑप्शन ए स्ट्रॉन्गर, नो इट इज बैड। कौन सा होगा, वेपर इंक्रीजेस बिकॉज मोर नंबर ऑफ vapor pressure increases because liquids A and B can escape from the solution. More number of molecules of liquid A and liquid B can escape from the vapor pressure of the solution decreases because less number of main यहाँ पर reason क्या आ जाएगा, A and B interactions are weaker than those of AA and BB. ठीक है, so D option is correct. Even though I can say B option भी correct ही होगा, vapor pressure of the solution increases because more number of molecules of liquids A and B can escape from the solution, है ना। तो B option भी सही है, yes or no? क्या ख्याल है फहद, इरम? है ना, बी ऑप्शन विल आल्सो बी करेक्ट। दोनों ऑप्शन सही है यहाँ पे। ओके, मूविंग ऑन, ट्राई दिस वन। The mixture which shows positive deviation from Rod's law. The mixture which shows positive deviation from Rod's law. Yes, Fahad correct, Faiza correct, very good. Yes, Iram correct, very good. अभी तो लिखाया था ना, एग्जांपल्स में लिखा होगा, जिन्होंने लिखा होगा वो आंसर करेंगे। इथेनॉल प्लस एसीटोन। राइट, नेक्स्ट। For an ideal solution, choose the correct option. Yes, Iram, very good, correct. Yes, Faiza correct, very good. Yes, Tarif, very good. Now it is correct. Very good, Tarif. Fahad, what about you? जी फहद। ए ऑप्शन इज करेक्ट, है ना। डेल्टा एच मिक्स इज इक्वल टू 0। ये बताइए, mixtures that form maximum boiling azeotrope. ये सीरम करेक्ट, फहद करेक्ट, वेरी गुड। देखिए मैक्सिमम बॉइलिंग का क्या मतलब हुआ? मैक्सिमम बॉइलिंग का मतलब हुआ पॉजिटिव डेविएशन, नेगेटिव डेविएशन,
Negative.
नेगेटिव डेविएशन, है ना? नेगेटिव डेविएशन के एग्जांपल में क्या मिला होगा आपको? वाटर एंड नाइट्रिक एसिड। सही है। नेक्स्ट मूविंग ऑन, और कर लीजिए कुछ कुछ सवाल आप लोग। Yes, Aram correct, Faiza correct, very good. Yes, Tarif correct, है ना? देखिए if आंसर सही आ रहा है आप लोग का, डेल्टा जी मिक्स विल बी, दिस इज इनकरेक्ट, है ना? डेल्टा जी मिक्स क्या होता है? नेगेटिव होता है, ठीक है। नाउ व्हाट अबाउट डेल्टा यू मिक्स? प्लीज सी, डेल्टा यू इट इज इक्वल टू, बताइए क्या होता है फॉर्मूला? डेल्टा एच और पी डेल्टा वी के केस में, ओहो व्हाट हैपेंड? डेल्टा यू इज इक्वल टू डेल्टा एच माइनस पी डेल्टा वी भी होता है ना, डेल्टा एच माइनस पी डेल्टा वी। डेल्टा एच क्या होता है आइडियल के लिए? जीरो। डेल्टा वी क्या होता है आइडियल के लिए? जीरो। तो डेल्टा यू क्या हो जाएगा आपके पास? जीरो माइनस जीरो, जीरो, है ना? जीरो इंटू पी विल बी ऑल्सो इक्वल टू जीरो, राइट? सो दिस विल बी ऑल्सो जीरो। ऑल ऑफ यू गॉट दिस? yes or no, please tell me.
Yes, sir.
Okay, let's see if we have some questions. चलिए यहाँ पे इस सवाल को देखिए। Such as the most important type of intermolecular attractive interaction in the following pairs. Write this down. See, you have to suggest what is the most important type of intermolecular forces of attraction in the following pairs, है ना? तो हेक्सेन और ऑक्टेन के दोनों के बीच में what type of intermolecular forces will be there? There will be van der Waals forces or London forces. London dispersion forces. दोनों क्या हैं? दोनों both of them are non-polar. That is why London dispersion forces. What फहद? अच्छा लंदन डिस्पर्जन, ओ सॉरी सॉरी, स्टेट्स ऑफ मैटर आप लोगों ने नहीं पढ़ा है ना? वैंडरवाल फोर्सेस जानते हैं? अच्छा बता देते हैं। देखिए you have, this is, let us suppose you have हेक्सेन का केस ले लेते हैं 1 2 3 4 5 6, ऑक्टेन 1 2 3 4 5 6 7 8, सो बोथ ऑफ देम आर व्हाट, दोनों के ऊपर कुछ इलेक्ट्रॉन डेंसिटी इस तरह से होगी, राइट? आई एम टेकिंग दिस एज स्मॉल ये, and I'm taking this as a bigger entity. All of them are having electron density over them. For a very minute amount of time, what happens? Let us suppose क्या हो सकता है, बहुत ही छोटे टाइम के लिए इलेक्ट्रॉन डेंसिटी इस तरफ ज्यादा हो जाएगी. So relatively, this side will be positively charged. And if it is positively charged, then octane का ये क्या करेगा? Octane के पॉजिटिव चार्ज यहाँ पे, तो यहाँ नेगेटिव चार्ज आ जाएगा. पॉजिटिव चार्ज विल अट्रैक्ट दी नेगेटिव चार्ज फ्रॉम दी ऑक्टेन, और एक पॉजिटिव टाइप का डाइपोल यहाँ पे बन जाएगा. ओके, सो दिस टाइप ऑफ फोर्सेस इज नोन एज लंडन डिस्पर्जन फोर्सेस. इंस्टेंटेनियस डाइपोल बनता है वहां पे, ठीक है, ऑटोमेटिकली अपने आप डाइपोल बनेगा एंड देन इट विल बी रिमूव. सो दैट टाइप ऑफ फोर्सेस इज नोन एज व्हाट? लंडन डिस्पर्जन फोर्सेस, और वैंडर वाल फोर्सेस ये बोलते हैं इसको. व्हाट डू वी से? वैंडर वाल फोर्सेस. इट इज बिटवीन नॉन पोलर molecules. These are known as London dispersion forces. ठीक है. Similarly, I2 is also non-polar, CCl4 is also non-polar. So यहाँ पे भी आपके पास क्या होगा? LDF, London dispersion forces. NaClO4 and water. What about this? NaClO4 is what? It is Na plus और ClO4 negative देगा ये, right? यहाँ पे क्या मिल रहा है आपको? You are getting ions in this case. What are you getting? You are getting ions in this case. And what is water? Water is a polar molecule. ठीक है. अब यहाँ पे आपके पास what type of interaction will be there? एक आपके पास ion है and water is polar, that means it is a dipole. तो यहाँ पे you will have ion dipole interaction. Is right? Ion dipole interaction. ठीक है. Next, methanol and acetone. In both of them, what are they? They both are having what? Methanol is also dipole, acetone is also dipole. इन दोनों के बीच में क्या होगा? Dipole dipole interaction. Both of them are polar. Dipole dipole interaction. Then you have acetonitrile, which is polar, and acetone, which is again what? It is both of them are again polar. ठीक है. ये भी polar है आपके पास. CH3CN. This is delta negative, अगर delta positive होगा. Similarly, acetone में आपके पास double bond O, CH3CH3. So this is delta negative or either delta positive होगा. This is again polar, and that is why they will be also having dipole dipole interaction. So please write all these things. I hope all of you have read this. Now there is a concept of solubility जो हमने बताया था आपको, क्या होता है? Like dissolves like, right? What is the meaning of like dissolves like? That means अगर दोनों के बीच में same intermolecular forces of attraction हो, then more soluble. ठीक है? If they will have same intermolecular forces of attraction, then it will be more soluble. So write this down. Based on solute-solvent interaction, arrange the following in order of increasing solubility in N-octane. सवाल को लिख फिर I will explain it. First of all, look at the solvent. It is N-octane. N-octane is what? It is non-polar. तो सबसे अच्छे से किसको डिसॉल्व करेगा? नॉन पोलर को डिसॉल्व करेगा. व्हाट इज नॉन पोलर हियर? साइक्लोहेक्सेन इज नॉन पोलर. KCl क्या हो जाएगा? आयोनिक. CH3OH, that is methanol. It will be what? This is going to be polar. Polar and also with hydrogen bond. ठीक है? और CH3CN क्या हो जाएगा आपके पास? It will be just polar. Now looking at these interaction, what I can say, non-polar सबसे ज्यादा soluble, cyclohexane is most soluble. After that क्या आएगा? उसके बाद आएगा आपके पास polar. Polar is CH3Cl. After that we will be having polar, that is with hydrogen bond, that is CH3OH. And उसके बाद आएगा आपके पास ionic. Ionic है KCl. KCl will be least soluble in octane. Right, next question, similar सवाल है. Because this is polar hydrogen bond and this is only polar. The polar hydrogen bond is stronger than polar. ठीक है? This is strong molar intermolecular force of attraction than CH3Cl. ठीक है? That is why non-polar, polar, this is the weakest interaction. उसके बाद कौन strong है? उसके बाद कौन strong है? उसके बाद strongest. ठीक है? Polarity के हिसाब से. Non-polar, this will be polar, this will be highly polar. उसके बाद ionic तो completely dipole हो जाता है वो, positive and negative charges. ठीक है? Similarly यहाँ पे देखिए, amongst the following identify which are insoluble, partially soluble and highly soluble in water. तो water क्या बनाता है आपके पास? Water forms hydrogen bond. ठीक है? Water is going to form what? Water is going to form hydrogen bond. तो जहां जहां hydrogen bond होगा, they are going to be, if you will have hydrogen bond in the solute, then they will be soluble. If there is polar hydrogen bond, then they will be partially soluble. ठीक है? If they are non-polar, then they will be insoluble. ठीक है? तो फर्स्ट ऑफ ऑल फिनॉल में होता है पोलर हाइड्रोजन बॉन्ड. ठीक है? Because phenol is having large benzene group and ये छोटा सा यहाँ पे OH वाला part होता है, that is having only hydrogen bond. This big group here, it is not having any hydrogen bond. So that is why phenol is partially soluble. ठीक है? Next, toluene, it is non-polar, that is why it will be insoluble. Formic acid, CH3, no, not even CH3. It's just H, double bond O, and then you have OH. So this OH and this oxygen, both of them they can form hydrogen bond. Okay. That is why formic acid will be soluble. Ethylene glycol. Ethylene glycol has two hydrogen OH bonds. CH2, CH2, OH, and OH. Okay. So here you have two OH. Water में भी दो OH होता है, and that is why एक OH वाला ये bond और एक OH वाला ये bond. So that is why both of them can form hydrogen bond, and that is why ethylene glycol is also going to be soluble. Chloroform. Chloroform is what it is. अच्छा, non-polar का. Chloroform, it is going to be insoluble because it is what? It is very less polar. Pentanol जो होता है, it is having polar OH bond 1, 2, 3, 4 and OH. So this big group, sorry, एक और carbon आएगा 5 and OH. So this big group is not having any hydrogen bond. This small thing is having hydrogen bond. That is why it is polar hydrogen bond, which is partially soluble. Write this down.